Welcome to the session on statistical distributions, the binomial distribution. The objectives for this session are to understand the model of the binomial distribution and comment on appropriateness, and also calculate individual probabilities for the binomial distribution. In an experiment or survey, when carrying out a number of trials, a random variable x can be defined to represent the number of successful trials. The variable x can be modelled by a binomial distribution b bracket n comma p if the number of trials n is fixed, there are two possible outcomes only, the probability of success p is fixed, and trials are independent of one another. If a random variable x has binomial distribution BNP, then its probability mass function is given by the probability of x equals r equals n choose r p to the power r times 1 minus p to the power n minus r. N is sometimes called the index. P is sometimes referred to as the parameter. C n choose r equals n factorial over r factorial times n minus r factorial, where of course n factorial is n times n minus 1 times all the way down to 3 times 2 times 1, and 0 factorial is equal to 1. This is convention. Also, if the probability of a success equals p, then we can derive the fact that the probability of a failure equals 1 minus p, since of course there are only two possible outcomes. Let's now have a go at an example to illustrate this. Pause the video and have a go. Press play when you're ready to view the solutions. Let's have a go at example 1 part A first. The random variable x is distributed binomially with n equals 9 and p equals 1/3. Find the probability that x equals 3. So let's solve this. We're going to use this highlighted formula. And applying it, we have probability that x equals 3 equals 9 choose 3 times 1/3 to the power 3, where of course 1/3 comes from p equals 1/3, multiplied by 2/3 from 1 minus p to the power 6, which comes from 9 minus 3, or n minus r. So tidying up gives us this expression here. And tidying up some more, we have 84 times 1 over 27 times 64 over 729, which gives us 1,792 divided by 6,561, which is equal to 0.273 to 3 significant figures. Now let's solve part B. We are required to find the probability that x is less than or equal to 1. So let's solve this. The probability that x is less than or equal to 1 equals probability that x equals 0 plus probability that x equals 1. So, plugging in the values, we have for x equals 0, this expression here, plus for x equals 1, this expression here. And tidying up gives us 2/3 to the power 9 plus 9 times 1/3 times 2/3 to the power 8. Which equals 11/3 times 2/3 to the power 8. Which gives us 0.143 to 3 significant figures. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at Part A first. The probability that a randomly chosen member of an A-level maths class also studies A-level literature is 0.2. A random sample of 15 members of the class is taken. Suggest a suitable model for the random variable x, the number of members in the sample who are studying A-level literature. So let's solve this. Of course, there are two possible outcomes. Taking A-level literature and not taking A-level literature. And we're going to define x, our variable, as the number of students who are studying A-level literature. The number of trials n is 15 because there are 15 members in the sample. The probability of a success is p. This equals 0.2. Therefore, x is distributed binomially with n equal to 15 and p equal to 0.2 as shown. And in this, of course, we're assuming each member is independent. And therefore, this is our suitable model. And now for Part B. We are required to use our model to calculate the probability that exactly 9 members in the sample study literature. So let's solve this. We have that the probability that x equals 9 equals 15 choose 9, since n equals 15 and r equals 9, times 0.2 to the power 9, since p equals 0.2 and r equals 9, times 1 minus 0.2, since, of course, 1 minus p is 1 minus 0.2, to the power 15 minus 9, which is n minus r. And this, of course, gives us 15 factorial over 9 factorial times 15 minus 9 factorial times 0.2 to the power 9 times 0.8 to the power 6. Which equals 0.000000 672 to 3 significant figures. And finally, for Part C, we are required to use our model to calculate the probability that less than 2 members in the sample study literature. So let's solve this. We have that the probability that x is less than 2 is the same as the probability that x is less than or equal to 1, which is equal to the probability that x equals 0 plus the probability that x equals 1. And plugging in the values as before gives us this expression when r equals 0 and this expression when r equals 1. And so tidying up as shown gives us that the probability that x is less than or equal to 1 is 0.436 to 3 significant figures. This brings us to the end of this session. If you have understood its contents, you should be able to understand the model of the binomial distribution and comment on appropriateness, and calculate individual probabilities for the binomial distribution. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.